Hello, Accelerated Math 7-8 students. We are turning to the table of contents so that we can start our third lesson of our videos, and I'm trying to find the name of it so that I can write it down. I think that it is called, if I remember right. Yep, okay. So let me get a pen, sorry. Subtracting integers and other rational numbers. So our last lesson, lesson 2, was adding integers and other rational numbers, and lesson 3 is going to be subtracting integers and other rational numbers. And this lesson starts on page 12. I believe. Yes, page 12. So I'm going to turn in my comp book to page 12. Hopefully you can get yours set up and then join me. All right, so what we need to talk about today is figuring out how to subtract integers and other rational numbers. That's the name of the title of this lesson. Make sure you get that written up the top. Our goal for today we are going to learn about the rule for subtraction and identifying distance. That's what we're working on, okay? The rule for subtraction and identifying distance. We kind of talked about distance a little bit yesterday in class, so hopefully you can remember what we were talking about with distance. The arrows were a little tricky, but I think we're going to be okay. The question is it possible to use absolute value to find the distance between a number and another number that is not 0? I know that's a really wordy question, but let's read it again a little bit slower. Is it possible to use absolute value to find the distance between a number and another number that is not 0? I'm going to let you think on that for a little bit. Hopefully by the end of the lesson you'll be able to answer that question and give me an example. All right, so first thing that I want you to do is you've been playing with adding integers a lot. And so today what I want you to do is you're kind of doing a trial for me to answer this question. And the question that I need you to answer is, are these the same? So the question is asking, is 8 minus 12 the exact same thing as 8 plus a negative 12? Okay, that's what we're trying to prove right now. Is 8 minus 12 the same thing as 8 plus a negative 12? Okay, so one of the ways that I was able to prove this, or to help you with that, is let's use our models. Okay, and I decided to use both models so that you guys learn them, because the more you see them, the more you work with them, the better you'll know them, and then you'll be able to use them all the time. So I decided that it would be easier for me to use the number line on this side and use the chips on this side, okay? So it says 8 minus 12. So I drew a number line. Always start at 0 with the first number. This is the first number, so start at 0, go up to 8 with my arrow. Then I noticed I was subtracting, so I had to go to the left, because that's how you subtract on a number line. You go backwards, and I had to go backwards 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the number I ended on, if you count it, negative 1, 2, 3, 4, was negative 1. So 8 minus 12 gives me an answer of negative 4. Okay, that's easy. I can handle that. Okay, so now let's talk about using the chip model for this one. So the first number that I see is an 8. So if you look really closely, and I'm sorry that my circles are small, but I was trying to fit everything on the page. So let's see what we can fit into this screen so you can actually see what we're doing. I'll scoot the book over a tiny bit so we can see it. Okay, so 8 positives. So there they are. 1, 2, 3, 4, 5, 6, 7, 8. 8 positives, just like we see. Then it said that I'm adding 12 negatives. Oh, well, that's easy with the chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I drew 12 negative chips. Does everybody see what we did? Awesome. Now I have to finish my job, and this is my funnest part with working with chips, is I get to create 0 pairs. Remember, this is called a 0 pair. A positive and negative make 0. A positive and negative make 0. Negative and positive is 0, and negative and positive is 0. Positive and negative is 0. Positive and negative is 0. 0 and positive is 0. Sorry. A negative and a positive is a 0. So all of these are 0 pairs because there's 2 chips. So 0 pairs are made by 2 chips, a positive and a negative. So we have 1, 2, 3, 4, 5, 6, 7, 8 zeros. Oh, but there's still some chips left. Well, what chips are left for negatives? So the answer is -4. Huh. Wow. So let's go back to our top question. Let me zoom back out, sorry. Okay, so let's go back to our question. Are these the same? So we just proved something in math. This is my favorite thing to do in math, is prove it. So 8 minus 12 is exactly the same as 8 plus a -12. Huh. I want you to think about that for a minute. Let's compare them, okay? Both problems start with a positive 8. Do you agree? Then what happened? This one is subtracting a what kind of number? What is 12? 12 is positive. So you're subtracting a positive. So positive, positive, subtracting. Wait a minute. Look over here. Positive, negative. Huh, look at it again. Positive, negative, and instead of subtracting, we're adding. So I'm wondering, could we say that subtracting is exactly the same as adding the opposite? Because this was a positive 12, it's now a -12. And we're no longer subtracting, we're now adding. So could we say that anytime you see a subtraction problem, all you have to do is add the opposite? Okay, wait, we have to try it. Let's try one. What if I have -5 minus 9? So we're saying, if we can prove this, we're saying that you add the opposite. So the first number, the first value, always remains. So if this is a -5, over here it's going to be a -5. Look, this was a positive 8, so what did it become over here? It remained a positive 8. Okay, so these are exactly the same. But what we're saying is, instead of subtracting, we can add the opposite. What is 9? 9 is positive here. So what is the opposite of 9? -9, that's right. So this one would be a -9. Do you see it? So now let's see if we come up with the same answers. Again, I'm using the number line on this side because it's a lot easier. So 0, -1, -2, -3, -4, Mrs. Nelson! Write it correctly. -4, -5. Okay, phew. So I'm going to draw my arrow starting from 0 to -5 because that's what that is. And then it says subtract a positive 9. Wait a minute. Subtract, so I have to keep going to the left, yeah? Keep going to the left. How many? 9. So I have to go 9 more. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, I almost fell off the paper. Sorry about that. So from here, I'm going 9 more. And what is my final answer? Well, 6, -6, -7, -8, -9, -10, -11, -12, -13, -14. So my answer, according to this number line, is -14 for this problem. So we got -14 here. Now let's do the chip model and see if it works. So I have 1, 2, 3, 4, 5, all negatives, plus 9 negatives. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Making sure I drew them correctly. And then it says to add them together. Well, that's easy. Just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And they're all negative. So the answer for this one is, oh, cool. It works. Okay, wait. So let's say it again. So, what is the rule for subtraction? Oh, that lighting looks horrible. Okay, let's try it again. Okay, there we go. So, what is the rule for subtraction? Get your book straight there, lady. Okay. Subtraction is the same as adding the opposite. Remember how I said that just a few minutes ago? Well, we now proved it. We proved it with this problem up here, and we proved it with the practice problem on the piece of paper. So now let's look down here. We're going to do it one more time. What if we had -4 minus or subtract a -8? Okay, so what we're saying is the first number remains the same, unchanged, always the same. So -8 stays, oh, sorry, I can't even read. -4 stays a -4. And then we change the subtraction to adding. And then we change the -8 to a +8, because up here it says subtraction is the same as adding the opposite. This is the number that becomes the opposite. What is the opposite of -8? 8. So again, -4, change subtract to add. -8 becomes a +8 because you're adding the opposite. Okay? And then we check it with the chip model. We have 4 negatives, 1, 2, 3, 4. We're adding 8 to it, 1, 2, 3, 4, 5, 6, 7, 8. Create our 0 pairs, boom, 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 boom. What are we left with? 4. If you did a number line on there, you would probably come up with the same thing. Okay? So the subtraction rule is subtraction is the same as adding the opposite. I hope you remember this. This is huge. Huge stuff, kids. Huge. All right. The next part of our goal was that we were also going to talk about identifying distance. You can't see it. I'm pointing to it and you can't see it. Identifying distance. So I'm moving on to a new page. Again, when I move on to the new page, I need to write subtracting integers and other rational numbers because that's our title. And then we're going to talk about distance for a minute. Okay? This is not new information, guys. You have been learning about distance for quite a while. Distance is the amount of space between two numbers. Any two numbers. So if I have this number line right here and I give you a -4 and I give you a 3, so that would be a -3, a -2, a -1, a 0, a 1, and a 2. Okay, so let's say we have this number line right here. The distance from here to here is called distance. So it says the amount of space between two numbers. The amount of space between two numbers, this number and this number. That is the amount of space. Okay. You can either count the spaces to determine the distance. Okay, let's count them. 1, 2, 3, 4, 5, 6, 7. So we're saying that this distance is 7. Okay? But there's another way you can do it, because what if you had -1 million and your other number was positive 5,423,282. Are you going to want to count? Oh, you can't see again. Are you going to want to count everything in between these two numbers? And if you do, oh my gosh, it's probably going to take you like 6 years, seriously, to sit there and count that far. Probably not, but it would feel like it. So sometimes, instead of having to count the hops like we did up here, there is a need for having a different plan. So it says, or you can subtract the two numbers and take the absolute value. Subtract the two numbers and take the absolute value. Okay, so let's subtract the two numbers and take the absolute value. Okay, so let's make sure. If we have -4 and we subtract 3, everybody with me so far? So subtract the two numbers, and we learned on the other page that if we leave -4 the same, this guy becomes plus. What is the opposite of 3? -3. We have 4 negative chips, 1, 2, 3, 4. 3 negative chips, 1, 2, 3. We have a total of -7 chips. So we take the absolute value, and the absolute value of -7 is 7. Boom, done. You just did it. Okay? Now, so let's do this one. -1 million, right, minus 5,423,282. So we're going to do the same thing as we did up there. We keep -1 million And instead, this becomes a plus. This is a positive, right? It's a positive sitting right here, but we make it a negative, right? And our rule that we learned yesterday was if you're adding two negatives, keep the sign, right? A negative plus a negative equals a negative, and you add them together. So this answer would be 6,423,282, and now we have to take the absolute value of that. So the distance for this one is 6,423,282. That's the distance. Are you going to want to draw that on a number line? I am not. So this is much easier. Let's read it again. You can either count the spaces to determine, you can't see. You can either count the spaces to determine the distance, or you can subtract the two numbers and take the absolute value. I kind of like the second one better, okay? All right, so we have some other ones that we can practice again. So -2 plus a -8, so we take our arrow to -2, then we continue our journey on down -8 spaces, and we find that that distance is 10, okay? -2 plus a -8 is a -10, take the absolute value, and you get 10 units, okay? All right, what if we have this guy right here? 13 minus a -3, so we have 13. You have to figure out on your number line how you're going to show that, okay? I would like you to fill in this number line if you can. Or you can do it this way, where this becomes an add and this becomes an opposite, and 13 plus 3 gives you 16. The absolute value of 16 is 16. So the distance, it would be 16 units. Here is showing it. Oh, I remember what I was wanting you to do with this one, is instead of using the number line, I tried it and I went, no, let's do it a different way, because I wanted to teach you an or. I hadn't had an opportunity, so I want to teach you an or. What if we have 13 positives, and we're supposed to subtract -3? Look at these 13 positives. Are there any negatives? So can we take them away? No. You should have answered no to both of those questions. There are no negatives to take away. So in order to get some negatives to take them away, we need to create 0 pairs. So watch, this part is so awesome. So because we have to take away 3 negatives, I created 3 0 pairs. Because when you create 3 0 pairs, look, 0 pair, 0 pair, 0 pair. When you create 3 0 pairs, look what showed up in our chip pile. The 3 negatives that we need. So now we had 13. We added 0 because this is 0, 0, 0, right? So we didn't change the value, but we have the negatives now. So my job now is to take away those 3 negatives. So you circle them and draw an arrow that says take away. So now they're gone. They're gone, but you have to figure out what is left. So count them. 13, 14, 15, 16. Ta-da! There's your 16 with the chips. Is that cool or what? So we identify what is left on this row. These 3 were taken away. Now we have 3 negatives to take away. Take them away, and when you're done, you count what's left, and 16 is what was left. All right? So where are the negatives to take away? You cannot take them away if they are not there, so we insert 3 0 pairs so that we can take them away, and we're left with 16 positives. The thing you need to know, more importantly than anything else in this lesson, is distance is always positive. Always, no matter what, always positive, okay? Kiddos, this lesson is really, really fun. You should, if you can, challenge yourself. Try a couple more of these with the chip model because it really is fun. I don't see anything that I left for you to do, so here's what I'm going to do. I am going to make 5 short problems that is going to practice adding in 0 pair chips, and you have to do them in the afternoon when you come to class, okay? All right, revisiting our question of the day really quickly. Is it possible to use absolute value to find the distance between a number and another number that is not 0? Kiddos, is it possible? Is it possible? The answer is absolutely it's possible. We just did it 2 times right here, okay? So I hope this is good. I hope you're understanding, and I will see you all tomorrow.